Hi everyone, my name is Sophia, and today I'm going to talk about the topic which is quite fascinating for me, and it's called the Byzantine generals problem. You may ask me why did I choose this topic, and I will answer that I chose this topic because it's one of those ideas that might seem abstract at first, but once you get it, you will understand how crucial it is to how the blockchain works and why we need it in the first place. So let's jump in and talk about the Byzantine generals problem. So, what is Byzantine generals problem? Imagine a group of generals from the Byzantine army, each commanding their own army while they're surrounding the city. Now here they need to agree what to command their army, either to attack or to retreat. The challenge here is that all the generals are in different locations and they use messengers to communicate their choice, attacking or retreating. Now, also another challenge is that some generals are traitors, therefore they send fake messages. So the challenge here is how to reach a consensus and act together even if some generals are liars and the communication isn't perfect. So this is the essence of the Byzantine generals problem. How to achieve trust and coordination in a system where some participants might lie and you can't fully trust the communication channels. So why is it important in decentralized systems? Now think about computer networks. In a distributed systems, we don't have a central server that makes all the decisions. Instead, we have multiple ones, which are called nodes, right? And they need to agree on things like transactions, data, or system states. But what happens if one of the nodes gives false information? Does the network become unreliable completely? No, this is exactly the scenario of the Byzantine generals problem, what is trying to solve. Just like with generals, but here with computers. In other words, the problem would be how do we reach agreement in a network where some actors might be faulty or malicious? That's the real world problem. So, how does blockchain solve this? Here is where blockchain comes in. Blockchains are decentralized systems. No single authority is in control, and every node keeps a copy of the same data. To avoid chaos and fraud, all the nodes, all the participants need to agree on which data is correct, even if some participants are acting maliciously, like the Byzantine generals. Blockchain protocols like Bitcoin or Ethereum use consensus mechanisms, for example, proof of work or proof of stake, to make this decision possible. These mechanisms help all honest nodes reach agreement and ignore or override dishonest ones. In fact, data, the entire data of blockchain was built with the Byzantine generals problem in mind, and solving this problem is what makes decentralized trust possible. Without it, we'd still keep banks, servers, or central authorities to keep everything in check. And now, here's a real-world comparison. Imagine an online voting system with no central server. Each vote is sent to multiple servers. But what if one server lies about the results? Or what if it goes offline? You cannot just trust one single server. You need for all the servers to agree on the results. That is kind of the practical application of the Byzantine generals problem. And that's the kind of challenge the blockchain is designed to overcome. So, to sum it up, the Byzantine generals problem is about reaching consensus in a system where some participants cannot be trusted. It is a classical problem in distributed systems, and solving it is essential for building a secure, decentralized networks. Blockchain technology offers a real-world solution to this problem, using cryptographic rules and consensus protocols. This is why understanding this concept is so important. It's the foundation of how trust is built in blockchain systems. So thanks for watching this video. I hope now you understand how an ancient military problem helped developing the most cutting-edge technologies we have today. See you in the next video and bye.